Now let's take a look at the integrals. There's verbs. Antidifferentiation is referred to as integration, or we'll say take the integral. The noun, the antiderivative, is referred to as the integral. The vocabulary here can really throw people off, but really all the antiderivatives that you are finding, we're going to do those same things and calling them either antiderivative or the integral. A lot of it has to do with just the notation. The indefinite integral creates the antiderivative function. The notation would be this funny looking s. That's the integral of little f of x d of x, which equals the capital F of x, that anti-differentiation function, plus c. So again, it's the same thing we've been doing, just a new notation. So this squiggly is what we call the integral sign. It tells us to find the antiderivative, and later on it might tell us where to find that antiderivative. The little f of x is what we call the integrand. It's the function we're integrating, or the function that we're finding the antiderivative for. The d of x is the differential. It just tells us which variable we are integrating with respect to. Remember, we used that in Leibniz notation. That c is the constant of integration, that arbitrary constant that could be in the antiderivative because the derivative would be 0. And the capital F of x, that is the antiderivative or indefinite integral of f of x. So there's the key piece there. That antiderivative function is also called the indefinite integral. Now, why are we calling it the indefinite integral? Later, we will find the definite integral where we will have lower and upper bounds, let's say a and b of our integrand. And instead of it giving us a function, it's going to give us an actual number. But again, that's later. So let's look at some of the more common integral or antiderivative formulas. We've already looked at the integral of 1 over x d of x. We found that to be the natural log of the absolute value of x plus c. We also worked with the power functions, where to find the antiderivative. We added 1 to the exponent and then divided coefficient by that new exponent, again, plus c. The antiderivative of a constant, remember that's the derivative of a linear function, so it would just be k of x plus c. We love e to the x because it is its own derivative, therefore it's its own antiderivative, e to the x plus c. And remember that the derivative of a natural function is itself, therefore the antiderivative is itself, but it's also multiplied by the derivative of the exponent. Therefore, the integral will be divided by the derivative of the exponent plus c. I would write these down somewhere, as well as maybe some of the vocabulary, and keep these handy. And pretty soon, you will not have to look at them anymore. So in example C part A, we are looking for the indefinite integral, also the antiderivative of that function. But we'll need to rewrite it to make it a little bit easier because we've got that ugly cubed root in the denominator. So notice I'm going to write that integral again to show that I am not taking that integral or the antiderivative yet. I'm merely rewriting it. So we're going to write the -5, which is the numerator, times r to the -2/3 dr. So I've only rewritten it. I've not started to take the antiderivative. So now let's work on it. So we're going to drop the integration sign, and we're going to add 1 to the 2/3, and then divide the 5 by that new exponent of 1/3. I'm going to go ahead and put my plus c because I always forget it. And that's going to give me a -15 r to the 1/3 plus c, which is the same thing as -15 cubed root of r plus c. Now notice in part B, it looks like we just have the integral of dx. We don't see anything else. So that means we haven't understood 1 and understood 1. And it's with respect to q, not x, not r. So the antiderivative of 1 with respect to q is just q, and then plus c. So be careful. A lot of times people think they're doing it right, but they just don't pay attention to which variable it's being integrated with respect to. So take a look at that differential. Now part C, it looks like we can start taking the integral right away, except for this guy here. We might need to rewrite it. So we're not going to take the integral yet. So we're going to leave that integration sign. 4x cubed minus e to the 5x. And we're going to rewrite this as plus 6x to the negative 2 minus 2 dx. Notice it's all in parentheses. And that's to show that we are taking the integral of that entire polynomial with respect to dx. Otherwise, if there was no parentheses, we would just be taking the integral of that first term. So now that we're actually going to antidifferentiate or integrate, we can drop that integral sign and we would get x to the 4th, 4 divided by 4, minus e to the 5x divided by that 5, x to the negative 1, 6 to the negative over negative 1, minus 2x, and then plus some constant c. Let's go ahead and clean this up. We get x to the 4th minus 1/5 e to the 5x minus 6 over x minus 2x plus c.